Okay. So, we are back again. So, similarly you can write now flux linkages of phase B and phase C. So, similarly you can write that for your phase B, psi B is equal to IA into LAB0 plus LAA2 cos 2 theta plus pi by 3. This all we have seen, just you put it now. Then minus your IB into LAA0 plus LAA2 cos 2 into theta minus 2 pi by 3. Then plus IC into LAB0 plus LA2 cos 2 theta minus pi plus IFD LAFD cos theta minus 2 pi by 3 plus IKD LAKD cos theta minus 2 pi by 3 minus IKQ LAKQ sin theta minus 2 pi by 3. Whenever you are going through this equation and these things, first thing is that figure 9 should be there in front of you. Second thing is all the nomenclature also should be there in front of you, and then you will find initially perhaps so many terms are there, but initially perhaps you will find things a little difficult, but it is not difficult. You keep the figure 9 in front of you and keep the your all the nomenclature in front of you, and then just write step C and write, you will find things are simple, right. And similarly for your psi C will be IA. Earlier in equation time we at equation 29 we wrote only psi A, psi B, psi C is not written. So, now directly we are substituting, but they are also looking at those figure 9, looking at figure 9 you can write for psi B and psi C, but directly we are writing here, right. So, psi C will be IA into LAB0 plus LA2 cos 2 theta minus pi by 3 plus IB LAB0 plus LA2 cos 2 theta minus pi minus IC LA0 plus LA2 cos 2 into theta plus your what you call pi by 3, right. So, this one your what you call your plus IFD LFD cos theta plus 2 pi by 3 plus IKD LAKD cos theta plus 2 pi by 3 and minus IKKQ LAKQ sin theta plus 2 pi by 3. So, now flux linkage for your psi B, psi C and all these things, right, all these things are your what you call derived, right. So, only thing is that I'll tell one thing, that as this course is particularly the synchronous machine part, as it's many mathematics are involved. So, if you find any writing error from my side, you please just send me a mail or put it in the forum. If any error you find particularly in this equation in writing, I will rectify that, right. Hope everything is correct, but if you find any error or if you have any doubt, please put a question in the forum, right. Now, stator part now is over, stator, rotor, mutual inductance, all this. Now, rotor circuit equation will come, because we have to see the rotor circuit means on the D axis you have field winding as well as armature winding. Similarly, on that your Q axis you have only armature winding. So, the rotor circuit voltage equation will be, field voltage will be P is actually that is your d by dt, right. So, this P is equal to d by dt. So, rotor circuit equation actually your EFD is equal to P psi FD plus RFD ID. This is equation 50, and your on D axis you have armature winding, and there it is your what you call circuit is a closed circuit. So, no voltage there. So, 0 is equal to your P psi KD plus RKD IKD. This is equation 51, and your Q axis you have another armature winding. So, 0 is equal to, because it is a closed circuit. So, 0 is equal to P psi KQ plus RKQ IKQ. All these things please refer to figure 9, right. So, just see the figure 9, this is a simple equation, right. So, this is your what you call rotor circuit equation. So, just hold on. So, the rotor circuit see constant permeance because of the cylindrical structure of the stator, right. So, the rotor circuit see constant permeance because of the cylindrical structure of the stator, right. Therefore, the self inductances of rotor circuits and mutual inductances between each other do not vary with rotor position. Only the rotor to stator mutual inductance vary periodically with theta as given by equation 44, 45 and 46. This we have derived, right. So, that means that the rotor circuit flux linkages may be expressed as follows. So, psi FD, looking at again, whenever I am writing this equation, all the time please see the figure 9, right, figure 9. So, in this according to the your direction of the current and how the flux linkages all have been told in the beginning, right. So, LFFD IFD plus LFKD IKD, right, minus LAFD into, take the projection of all the stator current in all phase A, B and C. So, it will be IA cos theta plus IB cos theta minus 2 pi by 3 plus IC cos theta plus 2 pi by 3. This is equation your 53, right. This your because this LAFD actually it is that mutual inductance between the stator and the rotor, right. So, this that means this LFFD IFD plus LFKD IKD and minus this your all these things this LAFD into the simple thing IA cos theta plus IB cos theta minus 2 pi by 3 plus IC cos theta plus 2 pi by 3, right. Similarly, for psi KD, because you have Emerson winding on the D axis also, again referring to figure 9 again and again. So, there also LFKD IFD plus LKKD IKD minus LKKD, same thing IA cos theta plus IB cos theta minus 2 pi by 3 and plus IC into cos theta plus 2 pi by 3. So, it will be LFKD IFD plus your LKKD IKD minus LAKD into this bracket the same term IA cos theta plus IB cos theta minus 2 pi by 3 plus IC cos theta plus 2 by 3. From the symmetry we are writing actually equations, this equation many terms are there, but just see the windings and just put it, that is all, very simple, right. Just hold on. So, similarly you have, just hold on, similarly you have your Emerson winding on the Q axis. So, there it will be LKKQ IKQ plus LAKQ, it will be IA sin theta plus IB sin theta minus 2 pi by 3 plus IC sin theta plus 2 pi by 3, because the angle between your what you call D axis and Q axis, it is 90 degree apart. So, that is why LKKQ IKQ plus LAKQ IA sin theta plus IB sin theta minus 2 pi by 3 plus IC sin theta plus 2 pi by 3. This is equation 55, right. Now, next is, because this all flux linkages, then your equations we have seen inductances everything, but this direct analysis is this slightly difficult. So, we will make some your what you call that DQ0 transformation, right, direct axis, quadrature axis and stationary axis, this DQ0 transformation. Now, equation 26, 27 and 28 and equation 47, 48 and 49 associated with the stator circuits together with equations 50 to 55 associated with the rotor circuit, right. This actually completely describe the electrical performance of synchronous machine, right. So, equation 26 to your 28, then 47 to 49, right, and together with your equation 50 to 55 associated with the rotor circuit completely describes the electrical performance of a synchronous machine, right. However, these equations contain inductance terms which vary with angle theta, right, which actually in turn varies with time, right. So, we have to find out some methodology such that things your what you call that analysis will be easier. However, this equation contains inductance terms which vary with angle theta, which in turn varies with time. This introduces considerable complexity in solving machines and power system problems. Therefore, a much simpler form leading to a your clearer physical picture is obtained by appropriate transformation of stator variables. One thing is there, that physical significance of this dq0 transformation. After doing this, your what you call a elaborate explanation will be given, right. So a much simpler form is that one, right. So now we see that combining equation 53 to 55, that is 53, 54, 45, the stator currents combine into convenient forms in each axis. This suggests the transformation of the stator phase current into new variables as follows, right. So we are going for dq0, that is your direct axis, quadrature axis and stationary axis, this transformation. Now if we represent, suppose if we assume that id is equal to, because here we are telling that from equation 53, 54 and 55, right, that is your these three equation, that is your this here it is 53, this is your 53, this is 54 and this is 55, right. So in this case, your what you call that your we see from equation 53 to 55 that stator currents combine into convenient forms in each axis. This suggests the transformation of the stator phase current into new variables as follows. Suppose if we assume, say id is equal to some constant kd into ia cos theta plus ib cos theta minus 2 pi by 3 plus ic into cos theta plus 2 pi by 3. Say this is equation 56. Similarly, iq is equal to say minus kq into ia sin theta plus ib sin theta minus 2 pi by 3 plus ic sin theta plus 2 pi by 3. This is equation 57. But what will be the value of kd and kq, right, that we will see. Now the constant kd and kq are arbitrary and their values may be chosen to simplify numerical coefficient in performance equation. In most of the literature you will find on synchronous machine theory, kd and kq are taken as 2 by 3 and this choice will be followed here, right. So kd and kq will be 2 by 3, right. With kd is equal to kq, if you take 2 by 3 for balanced sinusoidal conditions, the peak values of id and iq are equal to the peak value of the stator current as shown below. I mean, if we choose kd is equal to kq is equal to 2 by 3, then the balanced sinusoidal condition, the peak values of id and iq are equal to the peak value of the stator current as shown below. For the balanced condition, we know that ia is equal to im sin omega s into t. Im is the peak value. So ib is equal to then im sin omega s t minus 2 pi by 3 and ic is equal to im sin omega s t plus 2 pi by 3, right. This we know. Now if you substitute all these things, substituting in equation 56, I mean if you substitute in this equation, suppose in equation 56 you substitute ia, ib, ic expression, you substitute and then simplify. If you simplify that in this thing, then this will be substitute all ia, ib, ic in equation 56 and expression will be like this. And if you simplify, right, from trigonometrical this thing, your how to call trigonometrical application point of view, if you simplify, you will find id will be is equal to kd into 3 by 2 im sin omega t minus theta, right. So now if you choose kd is equal to 2 by 3, then this will be, then this product will be unity, right. If you choose kd is equal to 3 by 2, right, therefore your if you choose kd is equal to 3 by 2 kd is equal to 2 by 3, right, then it is 2 by 3 into 3 by 2. So it will be unity only, right. Therefore id will become im sin omega s t minus theta, right. So for the peak value of id to be equal, kd should be equal to 2 by 3. Similarly, equation 57, in equation 57 here, in this equation also if you substitute ia, ib and ic, right, then you will get this expression that your id will become iq will become minus kq into 3 by 2 im cos omega s t minus theta. So here also kq if you choose 2 by 3, then your iq will become minus im cos omega s t minus theta, right. Therefore it results in the maximum value of iq being equal to the peak value of the stator current. Then with both id and iq, their maximum value will become peak value of the stator current, that is im. right. To give a complete degree of freedom, a third component must be defined so that the three phase current are transformed into three variables, right. So, if you do so, since the two components of ID and IQ together produce, just a minute, since the two current components ID and IQ, right, together produce a field identical to that produced by the original set of phase currents, right. Therefore, the third component must produce no space field in the air gap, right. So, therefore, a convenient third variable is the zero sequence current, right. So, zero sequence current I 0 associated with the symmetrical component, that will be I 0 is equal to 1/3 I A plus I B plus I C, but for the balance condition I A plus I B plus I C is equal to 0, that you know. That means I 0 will become 0, right. Therefore, the transformation from the ABC phase variables into the DQ0 we call variables can be written in the following matrix form. Therefore, we can write that ID is equal to your this matrix cos theta minus 2 pi by 3 and cos theta plus 2 pi by 3, and second it is 2 by 3 is just 1 minute, 2 by 3 is multiplied, right. This is 2 by 3 into that first row cos theta minus 2 pi by 3 cos theta plus 2 pi by 3, right. And similarly, your what you call second row minus sin theta minus 2 pi by 3 minus sin theta plus 2 pi by 3, and third row half, and actually it is, if you multiply 2 by particularly the third row 2 by third into half means it will be 1/3 I A plus I B plus I C, and ID expression we have given that if you take KD is equal to KQ is equal to 2 by 3, there will be, it will be 2 by 3 cos theta I A plus this cos theta minus 2 by 3 pi by 3 I B plus cos theta 2 pi by 3 I C. Similarly for IQ, right, and this is half is taken because 2/3 then into half of I A plus I B plus I C. So, basically it will become 1/3 I A plus I B plus I C, that is nothing but is equal to I 0. This is actually equation 59, right. So, if you take the inverse transformation of this, if you take the inverse transformation of this, then it will become that I A, I B, I C will become basically it is cos theta minus sin theta first row 1, then cos theta minus 2 pi by 2 minus sin theta minus 2 pi by 3 1, then cos theta plus 2 pi by 3 minus sin theta plus 2 pi by 3 1, right. That means you will see that I A will be is equal to I D cos theta minus your I Q sin theta plus your I 0. Similarly, I B will become your I D cos theta minus 2 pi by 3 minus I Q sin theta minus 2 pi by 3 in plus I 0. Similarly, I C will get, right. So, if you make the inverse if you take the inverse transformation, I mean if you take the inverse of this matrix, right. The above transformation also apply to the stator flux linkages and voltage. This is same for stator flux linkages as well as the voltages, right. So, using the expression for psi A, psi B and psi C giving by equation 47, 48 and 49 that we have seen, right. Transforming the flux linkages and current into your DQ0 your component, right, and with suitable reduction of your terms involving trigonometric terms, we obtain the following expression. Now, if you look here, if we try to derive all these mathematics, right, all the derivation, then it will consume a lot of time. So, just certain things we have to keep it in our mind, right. So, now flux linkages also, voltage induced also, all expressions will be similar, right, only variables are different. So, if you do so, then you will find that psi D, psi Q, psi 0 same as before, like your this one, your ID, IQ, I0 2/3 into this one, same thing for flux, right, only variables is flux only, psi D, psi Q, psi 0 2/3, this is your cos theta minus 2 pi by 3, then cos theta plus 2 pi by 3, right. And second row is minus sin theta 2 pi minus theta minus 2 pi by 3 minus sin theta plus 2 pi by 3, and it is half same again, and this is psi a, psi b, psi c, right. Same for flux linkages, and therefore we can write psi d is equal to minus LA 0 plus LAB 0 plus 3 by 2 LA 2 ID, right. So question is that psi d expression we are giving, then we know psi a, psi b, psi c all expression, that you have to substitute. Psi a, psi b, psi c we have got it, that you substitute and just simplify. You put expression of, you take expression of psi a, psi b, psi c, put it here, right, and just simplify, then you will get psi d is equal to minus LA 0 plus LAB 0 plus 3 by 2 LA 2 ID plus LAFD IFD plus LAKD IKD, right. Only thing is that from previously we have derived psi a, psi b, psi c in terms of all these things, you put it here and just simplify, you will get this equation, right. Similarly, psi q will become minus in bracket LA 0 plus LAB 0 minus 3 by 2 LA 2 IQ plus LAKQ IKQ. Similarly, psi 0 will get minus in bracket LA 0 minus 2 LAB 0 I 0. Only I will request all of you, those who are listening to this, and when you will go through this, just you put psi a, psi b, psi c expression and just try little bit, right. Here I have to save some time. So in this case, now defining the following new inductances. Suppose if we define LD is equal to LA 0 plus LAB 0 plus 3 by 2 LA 2. This is equation 61. We are defining this is LD because it is related to psi d, right. That is why we are defining. Similarly, LQ you define LA 0, then LAB 0 minus 3 by 2 LA 2. This is equation 62. And similarly, you define L0 is equal to LA 0 minus 2 into LAB 0. This is equation 63. Now, if you do so, then the flux linkage equation will become minus LDID, that is psi d is equal to minus LDID plus LAFD IFD plus LAKD IKD. This is equation 64, right. Similarly, psi q is equal to minus LQ IQ plus LAKQ IKQ. This is equation 65. Similarly, psi 0 will be equal to minus L0 I0. This is psi d, psi q and psi 0 equation. And also we have seen ID IQ I0. It is psi d, psi q, psi 0, the flux linkage equations, right. Next is rotor flux linkage into in your again your dq0 components, right. So here also is substitution of the expression for ID IQ in equation 53 and 54 and 55. You just put the expression of your what you call ID and IQ, then what you will get? You will get this expression. This I request you to derive, right. Again and again I am telling, because it will take then few more pages, right. So just have patience and just do this, and this one actually psi FD will be LFFD, then IFD plus LFKD IKD minus 3 by 2 LFD ID. This is equation 67, right. Similarly, psi KD will be LFKD IFD plus LKKD IKD minus 3 by 2 LAKD ID. This is equation 68. And similarly, psi KQ will become LKKQ IKQ minus 3 by 2 LAKQ IQ 69, right. Therefore, again all the inductances are seen to be constant, because here no question of theta, right. That is, they are independent of the rotor position, because theta is equal to omega r t or omega s t, right, because synchronous machine omega r is equal to omega s, right. So again all the inductances are seen to be constant, that is they are independent of the rotor position. So it should however be noted that the saturation, actually we have not considered the saturation effect, and throughout this course we will not consider that, the things will be more complicated, right. So are not considered here. The variation in inductances due to saturation are of a different nature, and this will be treated separately. So we will not consider that saturation effect here, right. So it is interesting to note that I0 does not appear in the rotor flux linkage equation. This is true, we have seen it. This is because your zero sequence component of armature current do not produce net MMF across the air gap, right. While dq0 transformation has resulted in constant inductances is equation 64 to 69, the mutual inductances between stator and rotor your quantities are not reciprocal. The mutual inductances between stator and rotor quantities are not reciprocal means, for example, something like this. Actually, if you say A12 not is equal to A21, right. So that can be made reciprocal, right, when we'll go for per unit system for synchronous machine with appropriate base quantities, right. So that we will see later in detail. So for example, the mutual inductance associated with the flux linking the field winding due to the current ID, right, your that field winding due to the current ID flowing in the dx stator winding from equation, it is 3/2 LAFD, right. So it is 3/2 LAFD, whereas equation 64 the mutual inductance associated with flux linking the dx stator winding, right. Just see this dx stator winding, it is due to field current is LAFD. Here it is 3/2 LAFD from one side to another if you take mutual one, and this is your LAFD. So they are not reciprocal. Reciprocal means they are not same. I mean meaning is something like that, M12 not is equal to M21, that kind of thing. So we have to choose an appropriate base such that we can transform in the same per unit values, that will be seen later, right. So this problem is overcome by appropriate choice of the per unit system for the rotor quantities, that we will see later, right. Similarly, for stator voltage equation in that same your transformation dq0 component, right. Equation 26 to 28 are basic equations for phase voltages in terms of phase flux linkage and current, that we have seen, right. So by applying the dq0 transformation in equation 59, the following expression in terms of transform component voltage, flux linkage and current you will result. So you will get, what you will do, that equation 26 to 28, the basic equations is transform into your dq and 0, your what you call transformation, right, and use equation 59, right. And if you do so, you will get this expression, Ed is equal to P is d by dt. Ed will get P psi d minus psi q P theta minus RA ID. This will explain the meaning of P psi d and psi q P theta little later, right. Minus this is equation 70. Similarly, EQ is equal to P psi q plus psi d P theta minus RA IQ. P psi d means it is d dt of psi d, and P theta means d theta dt, right, because P is d dt. And similarly, here EQ is equal to d dt of psi q plus your d dt of your psi d dt of d theta dt, and this one will be d dt of psi 0 minus RA into I 0. This is 70, 71 and 72, right. For angle theta as defined in equation figure 9, again your what you call figure, just see that your figure 9 is the angle between the axis of phase A and the d axis, right. So question is, the term P theta in the above equation, actually it represent actually d theta by dt, that is the rotor speed, right. So we will explain it later in detail, all these things. Thank you very much. We will be back again.